My name is Marco Trombetti. I'm the co-founder and CEO of Translated, a company I co-founded in 1999, so it's been a while now. And since the beginning, the company has been doing translation AI plus multiple level of human reviews. And the symbiosis between AI and humans has been really, I think, the success of the company. In 2017, Translated was the very first application of the transformer that you all know. And you probably are all customer of Translated, but you don't know it. So if you've been using Google Translate in the past, we contributed for 14 years to Google Translate. We also, if you use it Airbnb or Uber, everything you find on their website for the last 10 years has been done by us, translating in 65 languages, all the chat between the guest and the users, every single piece of content on the website, up to the commercials on TV. So multiple layers of quality from pure translation AI to top creative content. And in this challenge, we had an incredible opportunity to understand what is broken in machines, in AI. And because you always have someone challenging the work of AI constantly, many times a day, we collected a lot of data to understand what is the current limit of the transformer, and now we can move forward. And so that presentation is about these things. So first, I need to introduce you to the problem of language translation. Because if you, from a user perspective, you will say, oh, Google Translate is good enough. You will say ChatGPT is good enough. But when you get into the real problems of the fact that you have a brand and you want your product to be understood by everyone and perceived in a positive way, that's a different story. Every single word matters. And we humans are very, very sophisticated in language. And so I'll show you a video that will introduce you to the problem of why humans and machines are different.
Make sense of it all. You watch and you show, and then you just know. Face to face, when feelings just right. Needs no explaining. I know you can see. Oh, hello, somebody who grows. You see me, you hear me, and it makes me glow. I go by the look in your eyes, home by the river, hold me be my mirror. Love, can you feel me? This is our human touch.
Language is the most profound manifestation of human intelligence because we summarize the entire world information into a very compressed form. And every single species in the world has developed what is called motor control, the capacity of going around. You know, and we all know that you cannot achieve superintelligence with just language, but this is what makes us different from any other species. And so through language, we cooperate, we design a future together, and we motivate ourselves into that language. No other species in the world have developed complex language. And that's the reason why language is the most important factor for human evolution. And if we unlock language understanding around the world, then we can attack the big problems. There's people that think that going to Mars is the most important problem for humanity. I do believe that understanding each other in the planet is the most important thing. And that is the problem you attack in doing language translation. So there is many ways we can try to estimate when we will get to the universal translator. One way is to try to see where we are in computation, data, and algo. And now, it's been evolving quickly. Now we are at the brain of the parrot, which is about 10 times smaller than the human brain. We have about 10 trillion tokens in training data when we build models, which is about 10 times more what humans receive in their life, if you convert all the input into the words equivalent. And we're using mix of expert, which is something which is still 2-3 times less efficient than the human brain to learn. So we don't have the capacity yet, but obviously, as you see from the progress, this is coming. Other people in the past have doing this. Ray Kurzweil, truly a genius, was able to predict the progress and when we will have the potential to build artificial general intelligence. He predicted that the human brain will be matched in 2023. I think he was wrong by some years, but the fact that he did that in the 90s, to me, chapeau, very smart. We don't like this approach anyway. So what we did at Translated, we did something different. For 20 years, we've been working with humans, so why don't we simply measure how long does it take to our professional translators to correct the errors of the machine? So we provide an AI, they correct the errors of the AI, we measure how much time they take. And this is the finding. So from 2025, the time it takes for equivalent word is getting down every single year. And for this conference, I updated the slides to get to 25. And you know what happened? This. And so if I go back, and then again, the progress is slowing down. For the first time, this graph goes back to 2010 really, and it was a straight line to singularity. The bottom, 1 second per word, is human singularity. It means that it takes 1 second per word to a human to say that a translation is perfect without changing it. So we were getting to that result in 27, and now this projection says 2030, 31, or 32. So something is not working anymore. In the recent years, we're not making the progress of the past. You will, as a user, you will experience it by saying, GPT-5 is not a breakthrough like GPT-4 was, and 5.1, same thing. And Gemini 3 is great, but a small improvement. When you look at the data, that's the reality. So how far can we go with the autoregressive transformer? Is this the problem? Well, the true thing is that there is a lot of things that we can still fix. And the things that I'm showing you are about our discoveries in real problems we find in translation. In translation, it's not like LLMs. It's based on an LLM, the technology, but you cannot hallucinate. If you hallucinate a little bit in an LLM, nobody will discover it. If you make a little hallucination in translation, you make everyone laugh. So it's a great gym for achieving artificial general intelligence because you cannot make mistakes. You need a perfect word model. So there is a certain limit, and I want to guide you through these things, and now we found these limits that we would like to fix. So that's the model that we've been using, and really we've been, since 2000, we've been training our own models from scratch. The foundation model and the fine-tune for the translation task. Neural started in 2010, was a big revolution, but only half of the model was neural, the language model. And the translation model instead was still statistical. Then Transformer was a big breakthrough, and that accelerated the path. And then for the last 2 years, we were not able to train anymore the full system. And so we started relying on OpenLLM as a start. Why? Because you see the training cost. It went from 100 hours for training our models, 100 hours, and then we went to 1,000 hours, which is still okay, and now we're 5 million hours for the fine-tune of the model. And so we cannot invest also the 20 million hours to build a model that will only last a year. It doesn't make sense. So we said, okay, let's rely on open source. And by working with open LLMs, we discovered what was broken. So that's why in 2026, we're releasing this foundation model that's called DUPS that will try to solve some of the problems that we found. And I want to share you the research ideas. So number one, that is broken is tokenization. Tokenization is a separate step in the process today. Most of our translation errors come from the fact that in tokenization, many sequences are very ambiguous. If I say CAS, this can mean multiple things. So when you convert that into the word embedding, it's very ambiguous. It can mean house in Italian, casa, it can mean a drawer, it can mean many things. And so that embedding is ambiguous. And when you inject ambiguity in the source, yes, the transformer is trying to fix the errors, but up to a point. And ambiguity brings a lot of errors. So first thing we need to do is to create a new tokenization technique that use the backpropagation of the entire network to learn how to tokenize efficiently for the task. More in general, going away from BPE and starting injecting only bytes. So not only you can inject text, you can inject images and videos to the model, and the model should learn how to tokenize that information as you process. This is exactly what we humans do. When someone taps me on the shoulder, my signals, neural signal, comes to me, and after a while, I know what it means. Nobody had to pre-process the information. If we can solve that, then we have a lot, way more data to train models on. The second thing we're working on is parallel reasoning. And so it's about doing the reasoning in latent space. So today, reasoning in models is done by chain of thought. The model does something, outputs something, and the input of the model to the autoregressive is putting back into the system so that you can try again. So if I try to translate this sentence, for example, in Italian, tre parole importanti, non sei solo. So every model, even the most sophisticated model, will translate as 3 important words, and then it will say, you are not alone. But these are 4 words, so this sentence, this translation is simply wrong. It should have been 4 important words, you are not alone. No transformer is able to do that because it's not able to count and decode at the same time. Our brain has something called functional connectivity. Different parts of the brains interact and reason inside the brain before we do the output. And you see me counting, and the model today cannot do it. So we need to move the reasoning, if we want to solve this kind of translation problem, into the latent space. And last thing, you cannot achieve superintelligence. You cannot achieve a machine that is better than the cumulative intelligence of the planet if you train on past human data. So if you want to do something bigger, then you need to learn, you have to let machine learn by experience, by doing stuff. And this is really how we learn. There is only a small fraction of our learning that comes from supervised fine-tuning. We reading books or reinforcement learning, us trying to ride a bicycle. We don't have anyone that tell us what the reward function is, what the value function is for something. We build that ourselves based on what we want to achieve, based on our agency. So we need to build that. We need models that are able to learn while they do inference. As we're doing stuff, we can break down problems and estimating the value function of that activity and training again the model. We actually did that in translation in 2017 and worked great. It was probably the reason why Translated became almost a $100 million company. And I think we would like to scale that approach from translation into more general application. And so Europe was very nice and granted us a 30 million euro research grant to achieving that. So it's one of the 2 flagship European research projects today. And we're also receiving another 100 million of compute grant. So we have, I think, what is enough for the first 2 years of this roadmap. So the good news is that we plan to ship this model as an open weight, open source model that try to attack these 2 problems in 26, in the range of 10 billion parameters, probably at 27 billion parameters will be available. And obviously, it will be available on Scaleway first. And then in 27, will be bigger, and 28, the final model. That includes all the features. Now, these are probabilities. The percentage you see because it's research. So we understand the problem. We don't know how to solve it yet 100%. So we hope to deliver that. So short, if you're interested about translation, well, you can try our translation tool online. For the first time, we made it available to consumer too. It's laratranslate.com. One feature you should look is the fact that the model is able to explain you why it did the translation. Big difference compared to Google Translate and all the systems is a machine that is able to explain why you used one term or the other while doing the task. And if you're interested in the research part, that's 70 researchers from Oxford, APFL, ATH, and we translated as coordinator that are working on these challenges. If you're interested in one of those research challenges and you think are interesting for your work, reach out to me. That's the email. Thank you so much.